Go ahead and just do a quick review of how to solve a system of equations. There's three methods that you can use. The first and easiest method is the graphing method, in which case you graph each equation on the same coordinate plane and you look for where they cross each other. So in this particular example, I graphed this first equation, 2x plus 3y equals 6. That's this purple line. And then I graphed the second equation, x plus 2y equals 3. That's the second equation. And I looked for where they crossed each other, and they crossed each other at this point, 3, 0. That's going to be my solution. My x value is 3, my y value is 0. And the easiest way to do that is to just use Desmos, graph both of the equations, and you're just looking for where they cross each other. This method is not always permitted. Your teacher is probably going to be asking you to solve the system and demonstrate that you understand how to solve it using substitution or elimination. But if that's the case, you can always use the graphing method to check your answer if a graphing calculator is available to you. But for just so you know, there will be situations where your teacher wants to verify that you know how to use the substitution method and you know how to use the elimination method. So please don't think that you'll always be able to use the graphing method. You can always use the graphing method to check your answers, but you will be required to demonstrate that you know how to use these other two methods. So I'm going to just quickly show you the substitution and the elimination method. Just one quick example. I'll do more examples in another video. Right now, I just want to show you quickly what they both look like. So if I were to solve this same system using the substitution method, I could do that. The substitution method is good to use if one of your equations has a y equals or an x equals. And in this case, we do have that. We have x equals this quantity right here. And that tells me that this system of equations can be easily solved using the substitution method. What I'm going to do is I'm going to take this quantity that x is equal to, and I'm going to substitute it for the x in the other equation. Just going to substitute this quantity for this x. So let's rewrite that top equation. Instead of 2 times x, I'm going to write 2 times 2y plus 3, and then just rewrite the rest of the equation. Hopefully you're noticing that you now only have y's. You just have y's. That's your only variable, and that's a good thing. The whole point of the substitution method is to get rid of one of your variables so that you can solve for something. So now we're just going to solve for y. We can combine like terms right here. We can eliminate so that we have the y by ourselves, and we'll get y is equal to 0. Now what you can do is you can take that y equals 0 and you can substitute that value for y into either one of these original equations. It does not matter. Go ahead and choose the easiest looking equation, and I like the bottom one. So I'm going to do x equals 2y plus 3, except I'm going to substitute this 0 for this y right here. Those turn into 0, so x equals 3, and you can see the solution is this 0.30, and that's exactly what we got when we graphed it. We just found the same solution using the substitution method. And then lastly, I'm going to show you how to use the elimination method. Like I said, this is just a quick introduction, so I will do another video where I do more examples of substitution and more examples of elimination. Right now, I just want you to see what they look like. So to use the elimination method, we'll pick this same system. And in this case, what you want to do is start with 2 equations that are already in what's called standard form. So standard form is just where you have your x and y term on the same side of the equal sign. And in this case, we have that in our top equation, but our bottom equation does not have that. So what we're going to have to do is change around the terms in our bottom equation in order to make it in standard form. So I could subtract the 2y. Whoops, I'm sorry. I wanted the x term to come first. So I have x minus 2y equals 3, and now it's in standard form. So my original equation, 2x plus 3y equals 6, I didn't have to change that at all. It was already in standard form. But my second equation, I had to move around the terms in order to get it into standard form. So now it's in standard form. And what you would do next is try to eliminate one of the terms. So you should be able to add the equations. And if you were to add, one of your terms should be eliminated. So 2x plus 1x, those are not going to get eliminated. They're just going to add up. And then 3y and negative 2y, those are not going to get eliminated either. So the problem here is that we have to create opposite terms. So if we don't already have opposite terms, then we have to create them. And we can use the distributive property to create them. For example, if I multiply my top equation by 2 and my bottom equation by 3, what's going to happen is I'm going to have a positive 6y and a negative 6y. So when I add those equations, the y terms will eliminate. So let's go ahead and change our top equation. That's going to become now 4x plus 6y equals 12. Our bottom equation is 3x minus 6y equals 9. And the good thing is that when I add these equations now, my y terms get eliminated. So now I can solve for one of my variables. If I divide by 7, I'll get x equals 3. And now that you have a value for one of your variables, you can substitute this x equals 3 into one of your original equations. Let's take this one because it looks the easiest. X is going to be equal to 2y plus 3. I'm just going to substitute the 3 for this x value, and then I'll solve for y. 0 equals 2y, y equals 0. So you can see I got the same solution. The solution is x is 0, x is 3, y is 0. And I got the same solution using the elimination method, the substitution method, and the graphing method. That's just a quick introduction to all three methods of solving a system of linear equations.